Okay, 2012 AMC. This is problem 11 from the AMC12A, and it's a fun little probability problem. It says Alex, Mel, Chelsea, and Chelsea play a game that has 6 rounds. In each round, there is a single winner, and the outcomes of the rounds are independent. Okay, that's important. For each round, the probability that Alex wins is 1/2. So let's have Alex be blue. Alex wins is 1/2. Mel is twice as likely as Chelsea to win as Chelsea, okay? So, what we know from this is Alex has a half probability to win. And I'll write that. So, Alex has a 1/2 probability to win. And they don't really say it. I'm going to put it down here. It's not quite as useful, but Mel has a 1/3. And Chelsea has a 1/6 because there's half left and they should be in the ratio of 2-1. But the 2-1 is going to be much more important to solving this problem. Okay, so here's how we go about this. We have 6 rounds, and first I'm going to make sure that Alex wins 3. That's what we want to have first. So Alex wins 3. Which means he also loses 3. Okay, so loses 3. So he has a half probability of winning, so that's 1/2 to the 3rd power that he wins 3. And he has a 1 minus half, so he has a half probability of losing, so that's also 1/2 to the 3rd. And he can win any of the 6 choose 3. He has to win 3 of them. So any of the 6 choose 3 possible games he can win. And so 6 choose 3. Well, that's 6 factorial over 3 factorial, 3 factorial. NCR. And I still have, let me reduce this down to 1/2 to the 6th power. Now this right here, this 6 factorial over 3 factorial, 3 factorial, well, this 6 factorial and this 3 factorial somewhat cancel, so I have 6 times 5 times 4, but these 3 times 2 times 1s cancel. This 3 factorial is still left. And this 1/2 to the 6th is going to be 1 over 64. And now let's see what we can cancel out. So 3 times 2 times 1 is 6. So 6 over 6 is 1. 4 and 64. 4 goes into 64 and it goes into there 16 times. So this means that the probability that Alex wins 3 and then loses 3 is 5/16. Okay, and now we need to deal with Mel and Chelsea. So there are 3 left. We know that Alex already lost, so I'm going to put lost 3. So there's no probability to this. This happened because of this. We said he lost 3 already in this 5 out of 16 times. So from here, we don't need to worry about this. So given that Alex lost 3, let me see. So the probability of Mel, let's see if I'm doing this right, given not A, so given that Alex doesn't win, is now 2 out of the 3. He's twice as likely as Chelsea, so 2/3. And the probability of Chelsea, given that Alex is not winning here, because we've already said Alex has lost here, is 1 out of 3. So you can see that we have a total whole. One of them has to win here. There's always a single winner, but Mel is twice as likely as Chelsea. And so I want, let's see, I want Mel to win 2 rounds Okay, so that means that I have 2/3 probability for Mel squared because he has to win 2 of them. I want Chelsea to win 1 round, which means I have 1/3 to the first power. And this can happen in, we have a few ways to deal with this, but let's just deal with Mel winning. So this can happen in any of 3 choose 2 ways, because we have 3 rounds, 2 of which Mel is winning. 3 choose 2 is 3 factorial, that's an I, 3 factorial over 1 factorial, 2 factorial. 2/3 squared is 4/9 times 1/3. 3 factorial of 1, well, that's 6 over 2, so that is going to give me 3 times 4/9 times 1/3. And 3 and the 1/3 cancel out. That's nice. May as well cancel them out here, save ourselves some time later. And so let's pull this all together. So what we have, this is the probability that Alex wins 3, and then 4/9 is the probability that then Mel wins 2 and Chelsea wins 1. So 5/16 multiplied by 4/9, and this 16 and this 4 can reduce down to a 4 and a 1. And that then gives me a probability of 5 times 1 is 5, 4 times 9 is 36, 5/36 that Alex wins 3, Mel wins 2, and Chelsea wins 1 in any order.